Okay, so in one of my previous videos, I said that one of the things it would be really good to automate is the process of breaking down a question to extract the information that we need. So what we're going to do is we're going to come up with the same process that we use every time we see a question that will enable us to essentially handle it properly. Okay, so the first thing we might ask is, why do we need to break down questions? So the objective of breaking them down is to clarify the information you've already been given, which might help you come up with a strategy to solve it. And the other thing that I think is useful for this is, if you read the examiner's report for exams, one of the areas that is most commonly there for people losing marks is they just don't answer the question because they haven't read it properly and broken it down effectively. So that's why we might want to do this. And the reason we want to automate this is so it's not taking up space in our memory. So, what are the key things we're going to try and identify? What is our process going to be for automating question breakdown? So, we are going to want to identify any quantities we've been given, including in taking in the units that they're measured in. And we're going to want to take in what we're being asked to determine and the unit it should be measured in. So, this one would be our automation process for calculation type questions. So, that's the thing we're going to do every single time we're working through stuff. So in one of my previous videos on um, units, I said the first thing we should do when you look at a question is scan through it for prefixes, and that still applies here. So we're going to do that before we do this next process. So we find the prefix, deal with that, blah, blah, blah. Now we're on to this one, breaking down the question. So what we're now scanning for is any quantities we've been given, the units they're in, and what we're being asked to find, and what unit we should find it in. Okay, so what we'll do is we'll actually take a look at some examples so you can actually see this in action. So we've got first thing we would do is scan through this, look for prefixes, and we can see there aren't any. So that's our first thing that we'd do. Next thing, what we're going to do is scan through and go, okay, so what are we trying to accomplish? Well, we're trying to work towards an energy. So that's what we're trying to get to. So we're going to try and calculate that energy. Next thing we look at is actually what the question is asking us to do. So as we can see, we're looking to calculate energy. So we're going to be doing some equations and stuff like that. So we're looking for the trigger word in the question. Okay, so we've found out what we're trying to work towards and what we're going to have to do to get there. So next thing what we're going to do is look for quantities we've been given and the units that they've been given. So essentially we've been told the temperature change is minus 22, because we said the temperature decreases by 22. And I will write this out. So having found that, I'm going to go, okay, temperature change minus 22. Then we've got mass is 0.5 kilograms, so we don't have to worry about any unit conversions there. And we've got specific heat capacity. Again, we're going, okay, so 4,200, again, no unit conversions. Okay, so now what we've done is we've identified the information that we have been given in the question. And I actually do write this down every time I'm doing a calculation. I'm pulling the information out of the question. Then we go, okay, so remember, we're trying to work towards energy. So now we're in a process where we can start analyzing and looking for solving strategies. So what we've done up to this point are the things that I have automated. So I do this same process every time I'm doing a calculation question. I look at, what am I trying to find? Okay, so this is a calculation question. I've identified that and identified the information that I've been given in there. So this process is my automated process. And then this is the thinking part that we need our working memory for. So looking at this information, the thing I'm seeing is we've got all of this stuff and going, okay, so what equation links these things together? Well, we need E equals mc delta T. That's how we're actually going to solve this question. So these stages, the parts in purple, are the things we need our working memory for. This is the analysis and reasoning. All the stuff we can see in red, I have automated and done on autopilot. Okay, so let's have a look at another question. Again, first thing we're looking for, what are we trying to do? We're trying to calculate the kinetic energy. Okay, so That's what we're trying to work to and how we're going to get there. So this is a calculation type question. So now we're like, okay, let's scan our question, find the quantities. So some information we want to pick up in a question is we're trying to find the kinetic energy while it's in orbit. So we need the information about the object while it's in orbit. So that tells us what to look for. So calculating kinetic energy, I need to go into my head and go, okay, so how do I do that? Oh, okay, I need half mv squared. So that information would need to be in my long-term memory, therefore it's not taking up slots in my working memory. So then we go, okay, so what do I need? I need to find the mass and I need to find the speed when it's in orbit. So let's go to the data. Here's our mass. So I'm going to go, okay, mass is 78,000. No unit conversion required. It's already in kilograms. Orbit speed, 7.5 kilometers per second. Now, following my automated process, I would have already converted that because that's what the first thing I do when I look at a question. So we do need a unit conversion, and I would have already gone, it's kilo, so I'm going to multiply, and I'm going to multiply by 1,000. That's 7,500. Now I'm in a position to actually do this calculation, do the rearranging if I need to, plug the numbers in, calculate our answer. So these things in red are all done by me on autopilot. So my process would have been, I would have already converted the 7.5 into 7,500 to start with. I would have converted the 7 days into seconds as well to start off with. Then I've scanned through the question, found what I'm trying to find, how I'm trying to find it, and then used the equation to pull out the right piece of information. Those are the processes I go through every single time. So what I want to show you now is how we can use the similar automated process to do the analysis of other types of questions as well. So we've got two children, A and B, sitting on a seesaw, and the seesaw is balanced, or in equilibrium might be another way of saying that. So if we're breaking down the actual question, so it says use the idea of moments. So what I'm doing now is I'm activating the knowledge I have on moments. So in my long-term memory, I know that moment is calculated by doing force times perpendicular distance. And I know that if it's balanced or in equilibrium, clockwise moment is equal to anti-clockwise moment. So that's straight away what I'm doing. I'm breaking down this question. What does this question actually want us to do? Well, it wants us to explain what happens, or it's an explain type question. So in my head, what I'm thinking, I need to be saying, I need to be having the word because in my answer. So X happens because of blank. That's what explain is telling me. Then when do we need to do that? We need to do it when child B moves closer to the pivot. So those are the things I'm pulling out and really breaking down. This is what I'm using. This is what I'm trying to achieve, and I'm doing it in this scenario. So let's actually see what that looks like. So these things I've done on autopilot because I do the same thing every time. I pull in the knowledge that I have, I think of what question type it is and the scenario in which I'm doing it. So let's actually put that into practice. So you'll notice in my answer, you'll see I've highlighted it in bold because I'm doing an explain type question. I need the because in there. So if child B moves closer to the pivot, the clockwise moment is going to decrease. Why? Because the distance from the pivot has decreased and the force is the same. And moment is force times distance. So if distance gets smaller, force is the same, moment gets smaller. So I've got, this is what happens because. Then you go, okay, so now the resultant moment, there is a resultant moment anti-clockwise because the anti-clockwise moment is bigger than the clockwise one. So again, we've got the word because in there because it's an explain type question. And then what's going to happen? Person A will move downwards because there is a resultant moment to rotate the seesaw anti-clockwise. So again, we've got the effect and the cause behind it. That's what because is in there for. Let's see a completely different context. So we've got a diagram of a water butt used to collect rainwater. A tap allows water to be collected from the water butt in a watering can. If the tap were placed higher up on the water butt, what difference would it make to the rate of flow of water from the tap? Explain your answer. So, key thing I'm pulling, what type of question? It's an explain type question. So what do I need in there? I need the word because in my answer going, this happens because of blank. Okay, so then I'm going, okay, so from the context, what information am I going to need here? Well, we need to know about the rate of flow of water from the tap. Well, the information that we need to have in our long-term memory is that fluids are caused to flow by pressure. A larger pressure gives you a larger flow rate. It's just like a larger potential difference gives you a larger current in a circuit. It's the same model. Okay, so what does this look like? Well, we need to think about what causes the pressure in this context. So the equation that's useful here is pressure is the density of the fluid times gravitational field strength times the distance below the surface. So you can see the further below the surface of a fluid, the larger the pressure is going to be. So that's going to be helpful in answering our question. So this is just what I've got from breaking down the question. I haven't written anything yet. I've got, what do I need to do? I need to say because, and how do I approach that? Well, I need to be thinking about pressure. So what does my answer actually look like? So pressure increases the further below the surface of the water, and that's because there is a larger weight of water above the tap. That's what's causing the larger pressure. Okay, so that's our because. If the tap were moved upwards, the rate of water flow would decrease because rate of flow and pressure are directly proportional. So if we move the tap upwards, pressure drops, therefore the rate at which water flows will decrease. So that's given our second because in there. So finally, what are we trying to take away from this video? So to start with, I looked at why we want to break down questions. So in terms of helping us to actually solve them and making sure we've actually answered the question. We've looked at what are the key things to identify, both in calculation questions and also in other types of questions. So, what are we trying to achieve? What are we trying to get to? What have we been given to try and solve it? And then looking at how we then actually process that information. So we go, doing the analysis part and that kind of thing.